Okay, Dan, we are recording.
I'd like to welcome everyone to what we're calling our SPSS Virtual Roadshow. This is Dan Baresi. I have some responsibility for our federal healthcare practice around predictive analytics. And James Parry will be conducting the majority of this session that you see here. He's running the screen. You know, he and I and peers of mine, we went to a few different client sites, and we did a demo such as this, and it was very well receptive, and there was a mix of people in the room, from researchers to statisticians to business people, and we all agreed that, you know, it would make a heck of a lot of sense to do something like this to a much wider audience. So we're going to go ahead and kick this off. I'll be monitoring the chat room. So if you have something very specific, go ahead and send it in the chat, and we'll try to get it answered. But James will be leaving some time at the end to review some questions if and when they come up. So I think without further ado, I'll hand this over to you, James.
Great. Thank you, Dan. I appreciate it. I appreciate everybody taking the time out of their day today excuse me, to come in here and check out our virtual roadshow. As Dan mentioned, my name's James Parry. I'm a technical sales specialist for IBM, and I've been working with predictive analytics for about 20 years now. And today we're going to go over basically the core of our predictive analytics offering, which is SPSS Modeler. So I'm going to give you a little bit of background about IBM SPSS Big Data Predictive Analytics. Most of you on the phone are probably familiar with SPSS in one form or another, probably SPSS Statistics, which used to be referred to as SPSS. For those of you who aren't, SPSS has been around a long time. We offer software in the form of text mining, data mining, advanced statistical analysis, and unique deployment technologies. We have a very large services arm, and we combine those to make great solutions for you. But we've been around since about 1969, so a long time now. And as you can see from the Forrester wave up there, we're right up there as a strong leader in the big data predictive analytics world. One of the key takeaways for today down at the bottom of the slide here is that we really do have this non-proprietary approach, which means that when you decide to jump into data mining, we're not going to ask you to take out and replace your pre-existing IT infrastructure, but we want to work with that. So we have what we call a non-intrusive integration, services-oriented architecture. We're database agnostic, so whatever you happen to be running right now and holding and storing your data in, we will work with that. So we do want to leverage your pre-existing IT infrastructure. Okay, so today we're really going to just talk about SPSS Modeler, and as Dan said earlier, we get in front of customers and they go, my goodness, I've never seen this before. I didn't even know you guys had anything like this. So today is really an intro tour of what this thing can do for you. And Modeler really enables researchers, analysts to jump in and quickly, rapidly gain insights and discover key insights and looking for patterns that might be hidden under the radar, trends in the data that you can't normally see with traditional statistical methods. And some of the things we like to talk about is this is a data mining workbench. So just think of any craftsman, and you all are craftsmen in your own right. You have all of your own analytic tools out there. Well, this is a place where we can centrally locate lots and lots of different tools, and we hope that it's easy to use, and it is a visual programming paradigm, and we're going to be looking at this in a little bit more depth today. It offers a comprehensive set of data mining algorithms, and for those of you out there that might have your own algorithms that you enjoy using and say, with the R project, we also natively integrate with R. We address structured and unstructured data, and unstructured data in this scenario is text data, things like Word documents and PDF files and web pages. We also support the whole data mining process, and I'm going to start out after this diving into what CRISP DM is, so we'll talk about that. We also have outstanding performance and scalability, meaning that we don't have a proprietary data source, so we're going to work with whatever database structure you do have, and we have the ability to, what we can do is we can push back the data mining into the database itself to make it a lot more efficient and quickly. Excuse me. And also, you'll see by the stream technology that we have here, that's very easy to reproduce your results over and over again, so it should be able to give you a very quick time to solution. And for those of you who aren't interested in graphic user interfaces and using hieroglyphics, these icon-based structure that we have, you can program if you want. So we have a Python-based programming language called Jython, and I know there's some sharp folks on the line, so keep in mind that we are showing this through the visual programming paradigm, but if you are a programmer and you feel like programming, you are welcome to do so. So because I'm talking to researchers today, I'm going to cover each of these bullet points from that email flyer that you received within this context of this idea of CRISP-DM. It's also known as the cross-industry standard process for data mining. And really, again, it's because you're research-oriented. You really already know what you're doing. Traditionally, you're traditionally trained in statistical analysis and rigorous research. So I feel like I really need to mention that there's an important distinction between traditional statistical analysis and data mining, even though they're both extremely important to the overall research process, right? So while traditional statistical analysis is hypothesis-driven, it's governed by strict model specifications, data assumptions, the condition under which a hypothesis is proffered, mathematically formalized, and the data are collected to be analyzed in pursuit of testing that hypothesis. Well, data mining, which we're going to look at today, and again, you could do both here, but we're going to focus mainly on data mining. However, this can turn the process on its head and start with lots and lots of data instead of going out to collect data. We start with tons and tons of data, which the researcher analyst, with the aid of automated and semi-automated analytical means, sifts through to try to find meaningful patterns and nuggets of insight. So it can often be, really hard to know where to start and when, in fact, some insight or discovery or finding is actually real and durable, and it's not just an artifact or a statistical artifact or a chance of, say, dirty data with outliers or misbehaving data or things like that. So this makes the CRISP-DM process all the more important because it gives the analyst a solid framework or an organizing principle from which to attack even the most complex data mining problem sets. It also makes it much easier to collaborate across multiple groups who have varying timelines. So CRISP-DM starts with this idea of a business understanding, which is it's really just a value statement, or what do you hope to accomplish through this data mining task. For instance, in today's example, some of the data I'm going to be using today, I'm interested in knowing what kinds of people respond positively to different drugs administered. And once we can figure out that, we can avoid, say, negative reactions to medications, and then maybe we can increase their quality of life of the people taking this medication and reduce the costs of, say, complications or readmission. So in a fully formed CRISP-DM project, we'd usually tie a dollar amount or a type of return on information based on using a data mining solution over, say, common wisdom, traditional methods, or flipping a coin. So as you can see from the interconnectedness in this depiction here within the diagram, just as many of the machine learning algorithms in data mining are iterative, so too is this CRISP-DM process. And once we look at the data and we audit the data, we may need to readjust our goals if we don't have the data we need, or we may need to set out to collect more. And that's the data understanding phase. Do we actually have the data we need to address the business value that we just talked about? So when we move over into the data preparation, it's really essential for any data mining platform, and that's a real key differentiator here. Any data platform out there, they need to enable the researcher or the analyst to actually engage in robust data preparation. Now, I've been data mining for a long time, and they have data mining competitions online, like KD Nuggets. You might have heard of the Netflix Challenge, things like that. Well, in some of these data mining competitions, more than 2,000 new features or fields were created to enhance the model accuracy, believe it or not. So, it's really important that you have to be able to have a robust data preparation tool. You can't just look at the data. You'll have to be able to manipulate that data. So the relationship between data preparation in the modeling phase is also iterative, as we may have to converge on a solution through many iterations of alternating data preparation and modeling. So right now, I know I'm talking to researchers out there. I can hear people talking about objections about type 1 error and maybe finding some artifacts, some statistical artifacts. So don't worry, we're only working on what I would consider a training data set. So in data mining, rather than relying on those probability values, the sacred p-value that we do rely on to decide whether a finding is important and durable, and it would actually generalize out to a population, we're going to take our final model and we're going to put it through a real test. So we're going to run it through an evaluation process, which entails validating the model against a holdout sample, or what we call an as-of-yet unseen data set, to see how well that model performs. If the accuracy of that model on the testing data is as good or better than on the training data, we might have a suitable model. And then once we have that suitable model, and that model has actually been validated, usually it's a model that does a much better job at predicting an outcome than, say, flipping a coin or perhaps some common wisdom. We can then move that into the deployment stage. And that's the last stage we're going to talk about right here. And deployment is where about 99% of organizations just fall down, right? Deploying a data mining model can mean a whole lot of things, but in today's hypothetical context, we want to be able to collect data on incoming patients and run their demographics and measurements, such as their blood pressure, cholesterol levels, sodium, potassium levels. We want to be able to run that through a model and predict, before we just administer a drug, predict what drug, based on historical measurements on similar people, they'd most likely respond positively to. And in this way, we can not only develop a complex topography, which you'll see in the form of rule sets, of different types of people who respond differently to different drugs, we can use that topology or that model in production to make real-time recommendations. And again, this is hypothetical. So today, please keep in mind that this example it's fabricated, and I didn't run this by the IRB, and this example is for illustration purposes only, just to kind of show you how the software works. Okay. So let's talk about the demo. In the flyer that you got today, or you got that hopefully brought you to here, we talked about being able to show you how IBM SPSS Modeler can help you access and join virtually any data type, right? And that includes big data. You hear about Hortonworks and Big Insights and Apache Hadoop, text data, all sorts of different types of data. And being able to visually interact with that data by, selecting cases of interest using visual querying, using your mouse, not having to type in complex Boolean structures to figure out and subset your data. But also, in today's world of automation, modeling and evaluation can be automated so we can quickly, with expert guidance that's been baked into this platform. This platform, we've had this platform since 1998. It started in 1994. Actually, Modeler is old enough to drink this year, so it's been around a long time. But we have that expert guidance to help you build these predictive models, help you select the predictive models, and automate that model selection. Now, keep in mind, we have that capability, but the absolute end choice is up to you. We can also incorporate R models in R data manipulation procedures with our native R integration. And we have unique deployment technologies, because what do you do with a model at the end of the day? So we have the ability to securely store these models, share and socialize predictive models, and collaborate. And we can carry a bunch of other intellectual assets like codes and nodes and things that you'll see today. So we can collaborate across the entire organization. And lastly, even though it's the first bullet point, within Modeler, you'll see that we've organized everything within the CRISP-DM methodology, so you can help keep complex multi-user data mining projects organized utilizing that. Okay, so the first point, and again, I'm only going to go over about 4 points. We probably won't go the full hour. I'll maybe give you some day back, and we'll see from there. And then afterwards, we'll open up for any questions you might have. So one of the promises we made that we'd see is that Modeler can join data from virtually anywhere. And what you're seeing here, these are screenshots of the platform I'm going to show you in just a few minutes. So we can offer all sorts of different types of joins. Basically anything a database administrator can do, we can basically do with Modeler, whether it's full inner joins, outer joins, partial joins, those kinds of things. You can also password protect your data source. So say if you send a stream off to someone else and it's connected to a proprietary data source, you want them to have access to it but not to be able to write to it. You can do that as well. We can connect to any database out there that's ODBC compliant. That's called the Open Database Connectivity Protocol. And that means basically anything like SQL Server, DB2, Teradata, Oracle, we don't care. We're database agnostic. Further, we know a lot of people, a lot of researchers use different tools for different phases in their analytics. So we can also natively read and write SAS files, as well as the R data model. For any of you who have dealt with IBM business intelligence or financial modeling, as you can see, we can read and write out to IBM Cognos and TM1. We can read in geospatial data. In our text mining add-on, well, it's actually part of what we call Modeler Gold, which is going to incorporate everything I'm talking about today. We can read all sorts of different text files, PDF files, PowerPoints, HTML, XML, all that kind of stuff. And a big differentiator, too, if you're getting into the big data world, our conversations daily turn more and more to big data. Keep in mind that we can analyze big data sources in place with Analytics Server. Other organizations might say they can analyze big data, but they're only telling you half the story. They might actually have to ingest that data. Frankly, data today are too big to move. So we spawn the processes, we take the analytics, and we push it out to the data, and they all come back with a little piece of a puzzle, like a mosaic. And they come back, and we can build results from there. So if you have petabytes or terabytes of data, and you don't want to have to move it and assimilate it and reformat it, we can do that. Okay. So let me show you how we would do that. So this is IBM SPSS Modeler. Again, this has been around a long time. SPSS actually bought this back in 1998 from a company called ISL over in Britain. So this is actually it started out as a British product. But rather than jumping in and kind of showing you a cake that's already been baked or a dinner that's already been made, I'm going to show you how does this basically work. So right now I have a data source node and I have an output node, and this is called a canvas because we're data miners, we're creative people. So on the canvas, I have these two nodes. And when I right-click on a table, I can just click on Run, and it'll go and get that data. So this is just showing me what is inside of this Excel file. So how did I do that? And this is how Modeler basically works. I'm going to go down to my data sources. And this is called a palette, so it makes sense if we have a canvas, we have a palette. And I look for my data source, and I know, well, my colleague said, hey, it's an Excel spreadsheet. I click on Excel. I'm going to bring it down here. And also, I think, Dan, you're not muted. If you see some screen lag, if I get ahead of my screen or anything, please let me know, okay? I hate to talk 10 slides ahead of where I'm at. So I have my Excel spreadsheet here. All I have to do is double-click on it. Go to the import file, go to my directory, grab the data, click open. I can preview the data without having to read it all in. I'll take the first 10 rows. And you can see I've got about 9 fields in 10 records. Okay, and this data, it may not make sense to everybody, but it's pretty straightforward. It's just each person, each row is a specific individual, has their age, sex, blood pressure, cholesterol, sodium and potassium levels, and it's historically recorded which drug each person responded to. Now, this could be a cholesterol drug, it could be a blood pressure drug. It doesn't matter in this context. We're just kind of showing you these are the data that we're working with here. Okay. So that, in essence, is how Modeler works. So all you do is you go down to the bottom, grab a data source, and this table right here is just showing me what the data look like. But as you can see, I'm going to click down through on the bottom to give you an idea that this is a full ETL tool, ETL extraction, transformation, loading. We have all sorts of record operations, sorting data, sampling data, aggregating it, merging, appending it. Field operations, and field operations are operations that work on the columns. When you see something like a derive node, most of you will see that as a DIM procedure or a compute procedure. That's how we create new fields. Binning, allowing us to take continuous data that reside on a continuum and put them into buckets. So all of these things are just set up to make data preparation much, much easier. We also have a node down here on the left called auto data preparation. So say if you're dealing with hundreds of columns and you're trying to find an answer off of those hundreds of columns, the data might need to be prepared, and you might want to test out the auto data preparation. And what that'll do is it'll generally massage the data, standardize the data. It'll do all the stuff that you usually do by hand for you, and it's always good to test against that. Okay, so what I said is that we can open up data of many different kinds. And if you'll notice on the right-hand side here, we have our streams. And a stream is what you see here. I can take this stream. I can save the stream to a local file. I can also store the stream to that repository I was talking about earlier, the collaboration and deployment services. I can save each individual node. I can copy. I can paste. Everything we do can be reused. So think of this as a perfect recycling program as well. So you don't have to reinvent the wheel every time you start a project. So if I go in, and I just clicked on this stream right here called Merge Excel, what I wanted to show you is, just like I opened up an Excel spreadsheet earlier, I can double-click on the Excel spreadsheet, and you can see what we have here is we have that same file, but it's coming from 3 different sources. So this is the demographic info. These are just tiny little files. Okay, well, this is the person's age, the sex, and the research ID that they were given when they came in. I also have a DB2 database. So I'm merging an Excel file with a DB2 with another Excel file. So I can double-click on that, preview, and now you can see, oh, these are the measurements that came from the lab. So what I'm getting at is it's really hard to analyze data in different locations, but with Modeler, you can leave the data where they are and just pull them in for analytics altogether, so you don't have to spend your time making master data files and all that kind of stuff. Every time I want to run this, I can just go back to the original data and run it that way. Or I could use an export node, if I go down here, and I could say, well, you know what, I actually want to write that into a SAS file and have a SAS file at my beck and call. Or I might want to write it back into an Excel spreadsheet or my master database, things like that. Excuse me. And the merge node is going to look for keys that are common across each of these data sets. You don't have to have a key. You can merge by order. You can do one-to-many merge, table lookups. You can do all sorts of different kinds. I'm doing a very simple one-to-one merge here. So when I click on merge, there was only one possible key. So there's only one variable that was the same across all of these data sets. I could have 5 keys because sometimes you have to in a very complex way merge files. So that's not a limitation here at all. And there are different types of joins down here, selection criteria, et cetera. And now when I right-click on this table, it's going to show me all of the data together. Now you might notice that, boy, that went really fast. How did it go out to a database and 2 Excel spreadsheets? Well, I cheated. See these little green pieces of paper that are stuck on these icons? What that is when you're running, say you're going to be using some data for quite a while, that's called a cache, and that loads it into local memory. As long as it's not, larger than how much RAM you have, that'll make your analysis go very, very fast. So I left myself a note over here. It says, ooh, show connecting to big data on a VM. Because I have a virtual machine that's actually connected to a big data farm, which is in IBM's SPSS Cloud offering. So some of you may not want to install things on your desktop. You might want to use us to host all of your analytic platforms. We can do that. And I'm going to switch over to just give you an idea, well, what does it mean to connect to big data? So right now we're just connecting to different types of data sources. So I've got this big data source stream. And if you go back down to my sources, you'll see that there's a different icon for each different type of source, whether it's a flat file, Excel file, anything like that. Excuse me. So we have Analytics Server. Now, I said everything was included today in Modeler Gold, and that's true. Our deployment capabilities, text mining, entity analytics, data mining, all that. The only adapter you need is for big data because, it's relatively recent, and this is called Analytics Server. And Analytics Server allows you to connect to and analyze within HDFS distributed file system. So that's a Hadoop distributed file system. And also the default, anyway, you can change the default, but the default file size is any file above 128 megabytes, it will automatically invoke Spark. And if you're not familiar with Spark, Spark is basically a memory mapped procedure, so you can use clustering technology so you don't have to keep reading and writing from a disk. So if you have terabytes of data out there, we can keep that in memory and utilize Spark to do that. The thing is, most data mining platforms out there, in order to connect to big data, well, you have to understand things like Spark programming or map-reduce programming. And there are people probably on this phone that understand how to do that. But for those of you who don't, when I go to select a data source, I just double-click on the data source, and it's already selected for me in this case. I can click and select different data sources out there. These data sources are usually created by an administrator, but I'll give you an idea of how they create them. So I click Launch Data Source Editor. I log in to IBM SPSS Analytics Server. And for those of you who are actually thinking about the back end of this, is who is managing this Hadoop cluster, we use Parry to manage all of the resources. So I can take a look at the details of the data source, which is really just the name and description. Who can I share this with? I only set up one admin today, but I could have all sorts of different users so people can see different tables. I have my file input. And as you can see, I go to my data sources. You can see the different data sources I have available to me. Oops. And if I want to, right now, I can just click, upload. I'm going to upload a data source from my desktop if I want to. And I can then preview that data here. So the only thing I want you to know today is that all of the workload management, the MapReduce code, the Spark code, that is all handled by Analytics Server. And today isn't training. It's more of just getting us, giving you an idea of what our capabilities are, because a lot of people think that, if we're going to get into the big data world, I have to somehow be a MapReduce programmer or something like that. And I just want to let you know that's categorically not true with our product. You do not have to. You can just connect right to big data and analyze it right where it sits. Okay? And in order for us to do that, not that you have to do it today. By the way, this just went out to the IBM cloud. It went to a Hadoop distributed file system, and it went out and it pulled this table that I wrote up to that earlier. All you have to do is log in to the Analytics Server to get on there. That is it. Okay? So that is accessing data from many different sources. I'm going to go back to my my normal place here. And what I'm going to talk about next is the ability to visually interact with this data. And don't worry, we're going to get to the modeling and all that stuff. And I'm going to just pop open this slide right here. So visual interaction just means I am able to click on output, like a table or a chart, and select data elements of interest directly from there. Because what good does it do to look at a chart and see an outlier and to go, oh, now I've got to go search for that outlier. Gee, well, it's got a high blood pressure. It's got a high cholesterol. Well, then you start guessing and trying to figure out, how am I going to get to that? Well, what we can do here is, rather than writing in this code, say I wanted to find all females with high blood pressure or something in my data set, I can go in and I can run a table and I can do a sub-selection from that table. So a lot of times data mining entails subsetting data. I am looking for more and more interesting little nuggets or pockets of data in there. So I'm just going to run a table. And this is a little bit more of a complicated stream, but I hope you understand it's really just going back to those data sources. The only thing I've done here is I've created a ratio variable. I'll show you that in a minute. But what if I did just want to just peek at, I'll just say males with low blood pressure. I can click on males. And anywhere I see low, click on that, and just say, well, I can generate a select node. A select node is just going to subset the data, but I can also generate a derived node, which means, I'm just going to create like a Boolean indicator, a flag variable. And so I can use those in regression later. I can use those in predictive modeling. So I'm going to do a select node here. Anytime you click generate, it puts a node all the way to the top left of your data set. And really, all I have to do is simply put that upstream. And notice I can just grab onto these little connector lines here and see, oops. This is what I actually did here. I was going to show this after I clicked the wrong button. But what I did here is I actually selected a case. So what that's doing, that was just a mistake on my part, but let me show you what it's doing. I clicked on a case, and then I said select case, and what that is selected that case, every single value that was unique to that case, it already typed it out for me, so that's kind of getting ahead of myself. Let me do this again. Very simply, connect. Oops, I already have a table written. By the way, all the outputs are up here on the right. So I could take that table again and say, I want males with low blood pressure, and say select node and. Notice I said records. That's what I did by accident. Now, all it's going to do is write in connect. And it's just a bunch of right-click connect. And now we can just see it wrote in the Boolean logic. Select if blood pressure is low and sex equals male. I can also change the name of this instead of generated node to select gender blood pressure, something like that. Boom. There we go. And now if I run this table, it will filter out any cases that weren't male and that didn't have low blood pressure. Hopefully that makes sense. And what I could do now is I could do more selection. I could just keep going in here and selecting and subsetting data more and more. Another thing I might want to do is I might want to select relationships that I find in a graph. So I'm going to run a graph right here. And this is called a web graph. A web graph is a really cool graph that I just don't think we see enough of. And what a web graph allows you to do is take several categorical variables and look at how they relate to each other. So I noticed that a lot of people, well, the thicker the line, by the way, the more concordance there is between low blood pressure, in this case, and drug C. So I can just go ahead, I click View Interaction so I can interact with the graph. And I have my little selection wand. And now I can just go ahead and say, select people with low blood pressure on drug C. And the same thing, say generate a select node or a derived node. A derived node will compute a new variable. And now I can just keep subsetting the data lower and lower. So now when I run this, you can see I'll have even fewer cases. Oh, drug C. I didn't have any low blood pressure left. Okay, watch this. There we go. Now I can just replace that. And then, okay, well, let me take a look and see what I did. I can look in here. Okay, so this is a rookie mistake. Notice how it says BPR is low blood pressure. I created a new variable here I forgot to talk about. So what I have to do is I have to include that variable in here. And what I did was because both cholesterol and blood pressure were just as low and high, they were just shown that way, I went ahead and I recoded blood pressure so that high is now equal to high blood pressure, low is equal to low blood pressure. So that's what I did there. And that's why it yelled at me. By the way, when Modeler gets mad, it turns red. And it tells you, this is what you did wrong. And that way it won't just run, and then you're not going to be uncertain if you did something wrong. It will let you know. So now we have everybody who's on drug C, and I can move them right next to each other if I want to take a look at them, and low blood pressure. Sorry for the hiccup there. So that's visually interacting with the data, being able to go out there and find relationships that are important to you, click on those, and then create and generate a stream downstream from there for the ability to subset that data. Okay. So second to last thing I want to do here is talk about automated modeling. Now, a lot of people may not be familiar with predictive modeling and what it does, but there's many different types of problem sets that we can handle here. So while Modeler has multiple algorithms for analyzing all kinds of data phenomenon, from things like data segmentation, entity resolution, basically finding out who is who when you're merging large data sets, predictive modeling, spatio-temporal modeling, temporal causal modeling, we have all sorts of different types of modeling out there to fit different types of problem sets. You might want to automate that. So we have 4 different automated, and these are the most popular types of algorithms. An auto classifier will run all classification algorithms capable of classifying that amount of output classes. So say if you're doing a binary output, yes, no, or multinomial outcomes, that's what an auto classifier will do. It'll take all possible algorithms and run them, and then they'll compete with each other, and we'll see that. Auto-numeric is for a scale or a continuous outcome. Auto-clustering is runs all clustering algorithms when you're finding groups of similar people, and that's very useful when you're trying to segment your data and find out who is different from whom. And also time series analysis, and time series analysis is for forecasting. A lot of people don't do time series because it can be really difficult to figure out what is the best time series model that will deal with your trend, cycle, seasonality, and help you to forecast. The expert modeler in Modeler will do this for you. So let's take a look at this. So I'm just going to go to my automated modeling, go back to my streams. All right. And what I have here is the same data I saw earlier. And by the way, remember earlier I said you could password protect your data? Well, streams can get unwieldy. They can get huge. So what we can do is I can select nodes I want to logically cluster together, hit my magic wand, and create what you call a supernode. And a supernode is just a stream within a stream. And I can right-click on that supernode, or I can double-click on that supernode, and I can say lock that node. And I can create a password right here. Now, if you think about it, if I put a password on there and I emailed this stream to somebody else, or I put it in collaboration and deployment services so they can check it out like a library book, well, they can go to that data, but they may not be data preparation people and you don't want them to mess with the data. Well, they can analyze it from that point on. They can create new variables and all that kind of neat stuff. Okay. So I put in something called a partition node because earlier I talked about training versus testing data. This will automatically partition the data into a training, testing, and if you want a validation size, what that allows you to do is model on a training data set and then apply those results to a testing data set to see if that model knows what it's doing, to see if it's actually doing something besides randomly guessing. Okay? And what this is the auto classifier. And I got the auto classifier from down here, the lower bottom of my screen. You can see we have the automated modeling right here. So the auto classifier came from there. And when I double click on the auto classifier, if I click on expert, you can see these are the models that are available to run that can actually predict that many outcomes, so drug A, B, C, D, Y, et cetera. So all of these models are selected. Some are deselected by default because they take a long time to run, like a KNN, K nearest neighbors algorithm. That's a powerful algorithm, but it's extremely intense, so you can turn it on if you want. But this way, you can run models faster. So I ran this. I'm not going to run it now because it probably takes about a minute, and we don't have all that time. But I'm going to double-click on this, and what it did was it said, oh, well, C51 is trying to predict which drug people would respond positively to. And you can see it was 100% accurate. Anytime you see 100% accuracy, you should question the data, but this is very combed, massaged data. And it's also scientifically based. So what you can see here is C51 took less than a minute to build, came out 100% accurate, and it only used 4 fields, so you can address issues like parsimony. Quest was 100%, but it took 5 fields, and the classification regression tree was only 97%, and it used 4 fields. So I might say, oh, C51 looks great. And now, again, I can actually use all of these models together. I can compare them, but I can also make them work together in what we call ensemble modeling. But I'm just going to, for time's sake, double-click on the C51 and say, well, what did it find out? So it's a decision tree algorithm, and it's trying to create some kind of typology. So what it's doing here is it's saying, well, people with a sodium to potassium ratio of under 14.642, they were most likely to respond to drug X. But if they had high blood pressure, they were most likely to respond positively to drug A. But if they were under 50 with high blood pressure, they would also be on drug A, but if they were over 50, they'd be on drug B. So I can click on these confidences. It can show me how many people are in each group. So 12 people fit this profile, and 100% of them fit this profile. But the thing is, I can't do anything with this. I can look at it, just like I can look at it with this big viewer screen here. I can turn the screen on its side, and I can see, oh, for drug A, they were under 50. Their age was under 50. I'm going backwards here. They were people with high blood pressure, which is right here, and they were people who had less than 14.62 sodium to potassium ratio. So what we're doing is we're looking for what we call more and more homogeneous subsets. We're trying to find the people that fit these profiles based on this historical data. One way, I could select just these people to look at those people that can interact with the output. So I can click on what we call a terminal node here, where 100% of the people were classified to drug A. Click on Generate, and I can generate a rule set or a select node. If I generate a rule set, here I'm going to generate them both. I'm going to generate a rule set, and I'm going to generate a select node and close this. So let's take a look at what I did here. So this is a rule set. In a rule set, we'll create new variables with these rules contained within them. So I can see people who responded to drug A are the people that I described already. So let's look at drug Y. There's one rule for drug Y. If they have a greater than 14.62 ratio of sodium to potassium. So I can see all of these. But again, unless I attach this to the stream, it's not going to select out the cases I want. So what I can do is I can use this little selection node. And all I have to do is connect this nugget. So this nugget is really the C50 output. Well, it has a few outputs in there right now, but it contains a C50 output. And I'll just preview this. And now what we can see is these are all the people on drug A, and they all fit the profile that was generated by C50. And if I double-click on the generated node itself, see, well, these were people that had sodium to potassium ratio under 14.62, blood pressure was high, and their age was under 50. So think about this. These rules can be hundreds and hundreds of leaves or tree branches deep. So it's important to be able to immediately click on select and subset the data without having to copy it to SQL, write it out in Java, copy it down pen and pencil. We allow you to get directly very intimate with the data and right down at the data level to be able to pull out what you need. So we looked at the accuracy of the models here, but we also have other ways of assessing the accuracy of the model. We have our regular gains charts. So if you think of lift, gains, response, profit, return on investment, or you want to use old school ROC chart for binary outcomes, et cetera, you can do that as well. We can run this and we can take a look. And what this will show us, oh, I put in a business rule, by the way. A business rule is just say you guys thought that this drug was good for males with high blood pressure, something like that. That's my business rule right here. The steeper this line is, the farther it is from what we call the null, the better the model performs. And so you can see we have model performance on training data and model performance on testing data. And really, if you've never seen one of these before, it's kind of straightforward. We just say, if I were to randomly select 40% of the people, I would expect randomly to get 40% of those people on drug A. So this is using drug A as the reference group. But if I were to use my predictive model and select this 40% of the people rank ordered from highest to lowest with the highest probability of being on drug A and use my predictive model, I'm at 100% gain. So basically it's saying this is a much better model than guessing. So that's what we're comparing predictive models to. So we have the ability to automatically choose which models out of all of those models down there, and you can see on the bottom here, there's a lot of models. Out of all of those models in there, it went through and it selected three competitors. C51 was the top model, and we could look at that model in many different ways to look at its utility, whether it's accuracy, whether it's parsimony, anything like that. So we have a lot of different ways of doing that. But what we want to do with this model when we're done with it is we want to be able to store new cases. So people that we don't know their outcome yet, but we have all of this learned information inside of this model. Okay. So when I take a look at this, that idea, it's called deployment, right? And what I need to be able to do is take in data. Now imagine we're in a clinic, and actually let me go back to my slide and set this up a little bit better than me just diving right into it. So now, once we have a predictive model built, and again, I didn't go through, perhaps the rigor we would generally go through day to day, because that's what they pay us for as researchers, to go there and really figure out and hammer on these models and make sure that these are good, durable, predictive models. But once we have that model built, what do we do with it? So organizing, conserving, and operationalizing results or acting on those results of a predictive model before the research question is obsolete, which is a big deal today, is really a great challenge for most organizations. And I put this word conserving in there on purpose because what happens when you have somebody working for you and they're the expert, we call it the hero model, right? Oh, this guy knows how to build models in R. And then one day they get a new job and they leave. You're left with a laptop with a bunch of code that maybe nobody can read, a bunch of models that maybe some people understand. But being able to take these models and put them, upload and share these intellectual assets to a secure audited repository that stays there long after people are gone, allows people to conserve those intellectual assets. You need something that's simple to navigate, just like it looks just like an Explorer, a regular file folder setup. So we have a simple to navigate repository with a tagging system, so we can tag things from, say, research group A versus research group B. So multiple groups can use this same repository and never see what other groups are storing in there, and they can choose differentially who to share their models, their code, their other intellectual assets with. And then we want to be able to take that model that we just built and put that into production. So let me show you how we would do that. So here's data, okay? And I am going to just preview this. Oop. Always something, right? All right. I'm just going to find out where I actually put my data. Okay. Looks like I didn't move my data there. 2 seconds. All right, I am going to so this is called batch scoring data. I just didn't have my data in the right spot. So, I mean, that's another thing. If you connect to the wrong data, it's going to let you know that you don't have the data that you thought you had. So I'm going to preview this data, and we're going to see everything here that you would collect from people on intake, but what they don't have is what drug would this person most likely to respond to. That's what this model is going to do right here. So that's the C5 model itself. I'm going to run in intake data, and then I'm going to run this through here, and you'll see it has the predicted value based on that model, so based on hundreds of exposures to having people come through responding positively or negatively to different drugs based on their blood pressure, age, potassium, sodium levels, et cetera. It's going, what is the predicted drug and what is the confidence around that? So you can see for person number 5, well, we think it's drug X, but it's less than 50% certain, so we might want to put them in a different protocol. That's an important step to realize. So we can take this model here, say file, and we can just store that in a predictive analytics repository. Okay, and once that's stored, we can go into that repository, and this is what the repository looks like for IT people. And you can see that that's the drug scoring stream that we saw earlier. I'm not going to go through it all because I'm running out a little bit of time here, but we started 5 minutes late. So what I could do is I can click on Configure Scoring, and it really just, all it does is ask you what data do you want to connect to. So what I'm getting at is now other people who don't have Modeler at all installed, other people that don't have Modeler installed but they have internet access can go to the content repository, and this is a thin client view into that repository we just saw, and they can go to the model. Oops. They can go to the model and they can begin to put in information. Well, what if somebody's 34 and they're a male and they have high blood pressure, high cholesterol, and their sodium and potassium level is at 10? Click score, and there we go. That's what we did. We just took that model from some guys, some analyst, male or female, somebody's desktop. We put it in a repository. We created a scoring configuration, which is just clicking through 2 or 3 steps. And we are now able to socialize that model out to other people. So, and this is actually just the development platform. We could make this into a really pretty website where they could log in and have your company's logo on there and all that. Now they know when these people like this come in, oh, well, we should put them on drug A. You know, that's where we should start. Or what if their potassium level is at, 50, something kind of crazy. Notice now they're on drug Y. So the model changes in real time based on that kind of information. Or I could batch input data, and I could have a bunch of people that we looked at over the last 2 weeks. I've got all their data. I just don't know. I mean, I have all their demographics and their measurements. I just don't know exactly what drug to put them on. And again, I'm just using this as data, but there's so many different problem sets we can work on. I click score, and now I can see that it scored all of these cases for me in a nice thin client interface. Okay, so that's what we mean by deploying a model, taking your findings from your desktop and then putting that into operations, whether it's a real-time website, whether it's clinical intake, it could be all sorts of different things like that. Okay. So that was a pretty fast hour, by the way. But I think we got about 2 minutes left in the hour. I hope today I was able to just show you how IBM SPSS Modeler really will enable the analyst to access and join all sorts of different types of data. Keep these complex multi-user data mining projects organized, allow you to visually interact with the data without having to be a programmer. You might be a subject matter expert who knows everything there is to know about, a particular molecule, but you never took a programming class in Python or SAS or something like that, but you know what you want to know. Being able to visually interact with your data, being able to quickly, with expert guidance, build predictive models and automate that model selection. And for those who are experts and want to use R in R data manipulation, absolutely. We have R integration with it, and just to prove that, and I forgot, I've got a couple of R examples right here, and this is kind of a neat one here, but this is what R output looks like. I can click on that R. Notice I can just cut and paste my R code right into Modeler, hit run, and this data has nothing to do with anything we were talking about today. This is data based on the TV series Mad Men. And it shows who was associated with who. I don't know if you can see, but Don Draper was associated with a lot of people. And it's probably a little too small for you guys to see. But in that way, I was able to take a nice web model, web chart from R and bring it into Modeler, okay? Also, this is a dialog box that I created because I wanted to be able to write univariate statistics right into the data model. This is an R run that was created in our dialog box creation facility. Okay, so now going back to finishing this up, because I forgot to show you guys R. And to be able to not only incorporate R and R data manipulation, which basically means everything R can do, we can do as well. We can also help you to deploy these models, securely store them, share, socialize predictive models, put them in real-time scoring processes, and other intellectual artifacts and assets to collaborate across the organization. And with that, I am going to say thank you very much for attending, and I hope this was informational. I hope you got some idea about what IBM SPSS Modeler, the data mining platform, can do for you.
And James, we're going to stay on. This is Dan.
Yep.
We're going to stay on just for a minute. If there are any questions from a few of the folks in the audience, we do have 5 minutes to spare for you all. So go ahead if there are any questions.
Okay.
I think you might have to open the line up.
Yeah, I am going to. Okay, I am unmuted. Wonderful. Okay, and I'm not sure, Dan, I couldn't really check the chat. I wasn't sure if anything came up question-wise from the chat, but
I did not see any.
Okay.
But we'll just wait one more minute to see if anybody shy wanted to jump in with a question, but we'll certainly be following up with you all. We appreciate you all taking the time, but we'll sit tight for another minute.
Actually, I know we've got some IBMers on the line too. If you guys have any questions, feel free. While you got me.
Yeah, right.
All right, but everyone's line should be unmuted. When people don't ask questions, I consider that abject crystal clarity. It was just so clear. There was just nothing to ask. Okay.
Yeah, smooth. That was very smooth, James. Yes, thank you.
Oh, I appreciate it. Yeah, I might have put some people to sleep too. My voice is a little gravelly today, so I apologize for that. Okay.
Well, this is Dan Baresi. My peers, I know Christy Chow had reached out to quite a few of you that are on the line, so we will be following up with you, but feel free to follow up with us. But again, we'll wait just a few more seconds here before we stop the recording if there are any questions. I think we're good, James.
All right. Well, I call that a wrap. So again, anybody who's still on, thank you. I did mute the entry and exit beep, so people could be exiting right now, and we definitely hope we do one of these again in the near future. We hope to see people again. And thanks for getting this together, Dan Baresi.
Thank you, James. Have a great afternoon, everyone.
All right. See you guys.